Okay, let's look at another example. Here I have a new array and the shape is 3, 2. So in the first dimension we have 3 elements, 1, 2, and 3, and in the second dimension we have 2 elements. So the shape here is 3, 2. Now we have A, which is I'm using NP A range, so that's going to A range and range. Range in Python, it creates range object. NP.A range in NumPy will give you a NumPy array fully deployed, all the elements fully expanded. Whereas the range function from base Python will only give you the range object, and the elements are not fully deployed. Remember that? So you have to use list or something to expand it. So here A range will give you an array. So it's just 0, 1, 2. So when I do the shape of M is 3, 2, and shape here is just 3. So this is 1 dimension, this is 2 dimensions. So here is the here is how that looks, right? Now when I apply the rule, so you again do the same thing, you add, so this one has smaller number, A has smaller number of dimensions, so you add a new dimension, this becomes 1, 3, okay? And the next step is, since the shape is not the same for the first dimension, then you expand. So match it to 3. So 6, 7, 8, 6, 7, 8, right? All right. But now the dimension is same, the shape in the first dimension is good, but the second dimension there is no 1. You have to have just 1 as the shape for you to expand. Suppose if this was only 1, then you can expand it to match. Or if this was only 1, you could expand it to match that. But if you do not have a 1 in a given dimension for the shape, then the rule fails. Only if the shape is 1, you can then expand it to match the shape of the other. So here it is going to generate an error. So this addition will generate the error. So it's important to understand why errors come up. So then you know why the error happened, and so you can take some preventive action or remedial action at that point. Okay? So when you add arrays for which the dimension and shape do not match, then the broadcasting rules will apply. Okay? All right, let's look at your turn here. Create a 3 by 4 NumPy array of random numbers from the range 0 to 9, and then you multiply by a scalar. So first step is to come up with an array. So we call it array Q9, ARQ9. Okay. So it has to be, so to create the NumPy array, you have to have this np dot array. And then we need to now specify the content of the array. So what should the array contain? Okay. The array is supposed to contain random numbers, okay, create a 3 by 4 NumPy array. So how many numbers we need? If you need 3 by 4, 12, we need 12 numbers. And each of those 12 numbers must be a random number, okay, in the range 0 to 9. So the random number comes from rand_int function, right? But that's part of NumPy. Within NumPy, you have the random number group. So np.random. And then you specify the particular kind of random number that we want, which is in this case rand_int. So inside we have np.random, okay. Then we want, okay, rand_int. So the different functions, I gave you a partial list of functions that come under random earlier, rand_int, rand_n, rand, and so on. So here, since it's integers that we want, so we do rand_int, and rand_int, the three things are the range, lower limit, and the upper limit from which you want to generate random numbers. So that will be 0, 9. And then the third is how many we want. We want 12. Okay. So now this is going to generate an NP array in one dimension with 12 numbers. Okay, but we want to reshape it to 3 by 4. So we do reshape three by 4. Okay, and let's just print it and see what it looks like. Okay, so for us to make sure that it's repeatable, so we need to do random np random dot seed and say 1. Okay, if you use the same seed, then you'll get exactly the same set of numbers. Okay? Okay, so now we have an array and we want to multiply the numbers with the scalar 5. So take that, multiply by 5, and then you get it. Okay, so that this multiplication, since it's a scalar, is performed on each and every element of the n-dimensional array. Okay, any questions? Good? Okay, create a one-dimensional NumPy array and add it to the two-dimensional array created above. So we have, so let's ARQ10. Okay, so that's now, will it work if I add ARQ10 to ARQ9? Will it work? So ARQ9 is shape is 3, 4, right? So that's 3, 4, and ARQ10 is just 4. Okay, it's just one dimension. So rule 1 is going to say, okay, we're going to do this. We're going to add a dimension to the left. And then when the shape is not the same, if you have a 1, then change that to match. So your 3, 4 will become, so now you expand this, then you get 3, 4. So now the shape matches, and therefore this addition ARQ9 plus ARQ10, okay, will work. It's not going to give you an error, right? Okay, there it is.